So something funky just happened with the video, so I'm going to pick up from here and hopefully we didn't lose the other information. So we're going to find the 5 y values, the sine values that go with our 5 key values in terms of x. We're going to graph those 5 points, and then we are going to connect them with a smooth graph to complete a cycle of the function. And then last but not least, we're going to graph one period, but sometimes we might be asked to extend this graph to the right or left to show more than the one period. So let's take a look at this first example here, which is y is equal to 3 sine x, and we're going to look to graph this between 0 and 2 pi. So between what we would anticipate is our normal period for sine. So let's identify information here. A is 3, our amplitude is going to be 3. And then B here, there's no number specifically written in front of that x, so we know that that's the invisible 1. B is 1. So what does this mean then? This means we know our amplitude, and now in terms of our period is 2 pi over b, which in this case is 2 pi over 1. So our period is 2 pi. So the period, it's going to take 2 pi to go through one complete cycle of this particular equation that we're graphing. To get our 5 key points, we're going to start with 0, and now we need 4 others. So how do we get those 4 others? We take our period here and we divide it by 4. So 2 pi over 4, which reduces to pi over 2. This is going to be the increment. So the period divided by 4, this is the increment we're going to use to find our x values here. So let's go ahead with this chart here. We're going to be starting at x is 0 because we're going to take a look at something called a phase shift, but not now. We're starting with basic. So we start at x is 0. Now, to get to our next key value, we take our 0 and we add our increment of pi over 2, which gives us pi over 2. So there is our next value. To go get our third value, we take our pi over 2 and we add another pi over 2. So now we get 2 pi over 2, or pi. Continuing from here, we have pi, and now we're going to add another pi over 2, and now we get 3 pi over 2. This is getting kind of squashed in there. Hope you can see it. And last but not least, we have 3 pi over 2, add another pi over 2, and this brings us to our 2 pi. So to get the 5 critical points, you start at your beginning x value. In this case, it was 0. And then you just continue to add the increment. So 0 pi over 2, 2 pi over 2, which reduces to pi. 3 pi plus another pi over 2 is 3 pi over 2. And then 3 pi over 2 plus another pi over 2 gives us 4 pi over 2, or 2 pi. So we have our 5 key values in terms of x. So now we find the sine of all of these. So we know these are going to be 0, 1, 0, -1, 0. We know that we have 3 intercepts, a max and a min. So for every sine function we graph, these are always going to be the y values we're looking to use when we use this method of 5 key values. So this would be our information. However, in this particular example, our amplitude has changed. Our amplitude is not 1 as it is in a basic sine function, our amplitude is 3. So for our final information for purposes of graphing, we have to take all our sine values and multiply them by 3. So all the intercepts are going to stay the same of 0 because 3 times 0 is just 0. Our max, which was at 1, is now going to be 3 because 3 times 1 is 3. And our min is going to be -1. 3 times -1 is -3. So now we have our x values and our y values, and we're going to graph these. So coming over here, at 0, we have 0, 0. So we are here. At pi over 2, we have 0, 3. So at pi over 2, we're up here at our max. At pi, we're back down to 0, an x-intercept. At 3 pi over 2, we're at -3, so we're down here. And then at 2 pi, we're at 0, we're back at an x-intercept. So there are our points. And now we connect them with, this is smooth and curved, there's no sharp. And here is our 1 period. We can see our 2 pi, our period of 2 pi that it takes to complete this cycle. I arbitrarily stopped here, but this graph would continue on. So on Desmos, I have graphed this so you can see what this would look like. So here, this green function here is our basic sine function where we have an amplitude of 1. So you can see between 0 and 2 pi, there's our 1 period of a basic y equals sine x function. This red one is the one that we just graphed here of y is 3 sine x. So on this graph, you can see that our 5 key values happen at the same x values. 0 and pi and 2 pi are all x-intercepts, we're zeros. At pi over 2, we have a max. For our function, it's 3 because we changed the amplitude versus 1 for a regular sine function. And then at 3 pi over 2 or 270 degrees, we have the minimum. Our function was -3 because, again, we changed the amplitude versus 1 of a regular sine function. But here you can see, besides the comparison of the two functions, that this graph continues on indefinitely in the positive and negative directions. We just were charged with graphing one complete cycle of 2 pi.